Okay, hi and good day everyone. Alright, for this video session, I will explain how you perform the estimation for ink sample data and how you perform what we call it as out of sample forecasting. Okay, it seems that a lot of you are interested to divide the data set into this what we call it as the estimation part and the evaluation part. Okay, so now I will show you how do we do it. Right, okay, so to work with R programming, okay, suppose that I want to show to you on how you perform box Jenkins model by using R programming while using the estimation and the evaluation data set. Okay, don't forget to load the required packages or library, okay, before you proceed. Okay, and then for this particular example, I will use our previous palm oil data set. Okay, alright, so based on my investigation, my palm oil data set, which is what I will perform box ranking model, is towards the production. Okay, how many palm oil production each month. Okay, right, so here I will read the data set into R first, okay, by using read Excel function, since that this palm oil production is in Excel file format, right? And then I will turn it into time series object by using TS function, okay, for which variables, tons variable. So how do I know I want to I want to use ton because when we investigate, the variable tons here represent the production, okay, the palm oil production. Okay, and my data start from 1989 and January 1989. So I will specify this argument start equals to C 1989 1. Okay, without specifying the end period. Okay, it is also workable here. Okay, and then frequency 12 because it is actually a monthly data, right? So when I run, I want to make sure that I'll read my data correctly. Okay, I have 120 observation, and this is data set. Okay, make sure that the first data set is correctly read by R. Okay, 1989 January. Okay, you have to refer back to your original. Okay, so this is my starting period and the end of the data that available in the data set is 1998, December 1998. Okay, make sure that you check this first before you proceed with the next step. Okay, and what you can do is plot the original series, okay, the entire series. Okay, right, so based on this series, okay, palm oil TS, okay, you can distinguish, you can explain, okay, what are the characteristic that that your series have. Okay, is there any trend, is there any seasonal? Okay, I will not discuss on that. I just want to show you the step. Okay, for here you can describe, okay, your data is from when to when, why there is a trend, why is a seasonal in your series, and so on. Okay, and then next we split the data, since that now we want to identify the Arima models. Okay, based what is the suitable Arima model for our series, and we will divide the data into estimation and evaluation part. Okay, some textbook they use word training and testing part. Okay, now I will introduce you the way how can we split the data. Okay, by using window function. Okay, for time series object, I will suggest you to use window function to split the data. Okay, suppose that for this series, okay, 1989 until 1996, I will use this as my estimation part, while the remaining is for my evaluation part. So how do I divide it? Okay, so for estimation window function, the series, and I will specify the end period. Okay, December 1996. For evaluation part, I will specify the start period 1997 1. Okay, January 1997, and then I run. Okay, don't forget to run. Okay, I run, and then when I check the estimation data, okay, this is my estimation data, and then this is my evaluation data. Right. So this is how you split the data into estimation part and evaluation part, and I naming this as this, so it is easy for us uh, to differentiate between the estimation and the evaluation series. Okay, now it is time for us to estimate the Arima models, to identify, okay, which is the best model to represent our series. But to find the best model for the first part, okay, the first part, we use the estimation series, okay, which is the first this is the first part to identify the Arima. So we perform the ACF and PACF for the estimation part series, and as we can see here, for ACF there is a wave-like pattern, okay, and also for PACF, so it means that the series is not stationary and also have seasonal component. Okay, so what you can do, you can perform the seasonal differencing first. Okay, so I use this name, I assign this C estimation.ts to say that this is the object after I perform the seasonal differencing. So how do I know that I perform seasonal differencing? Because I use this function, okay, by specifying the lag equals to 12. Okay, so this is seasonal differencing. So I run, okay, and after that I plot the ACF and PACF and also the original series for the object after I perform seasonal differencing. Okay, as we can see here, this is the pattern. It seems that the plot is still not stationary. Okay, and then it seems that even though that is a fluctuate on a constant value, but it suggests the series still not stationary, and the plot itself also show pattern, okay, wave-like pattern. Okay, and for your ACF also there is a lot of significant spike in your ACF, and it have decaying pattern alternately. Okay, so this is this is one of when we identify the stationary, we can explain this to justify whether our series is stationary or not. Because of what? We cannot read the ACF and PACF in a significant spike as until the series is stationary. Okay, but based on the ADF test, even though it will it give us p value less than 0.05, the value is quite high. Okay, 0.04864. Okay, so based on my justification, I will say that I will not stop here. Okay, I will not stop here, and I will perform non-seasonal differencing. This is actually the step here is actually quite tricky, I would say, because it is actually quite difficult for us to determine whether we should proceed or not, whether we have to stop to read the ACF and PACF. Okay, but again, it depends on your justification, and you should have reason, okay, why you say that you need to perform non-seasonal differencing after you perform season differencing. Okay, for me, I will perform non-seasonal differencing. I will not read this ACF and PACF to determine the order of our Arima models. Okay, right, so I perform non-seasonal differencing. Okay, non-seasonal differencing, this is the object name, and I perform differencing toward the seasonal okay, the data after seasonal differencing. Okay, right, okay, and then I look at the non-seasonal differencing, the original plot. It seems that now it fluctuates around constant value, which is 0, and you also we also don't detect any significant pattern in our ACF and PACF. Only a few of lags have significant spike here. Okay, so for this part, I will stop performing differencing. Seems that after I perform different seasonal and non-seasonal differencing, my series is already stationary, and then I confirm it by using ADF test, and ADF test also show me the p-value less than 0.05. Okay, so I will stop here. Okay, so based on my ACF and PACF, and how many significant spike. Okay, for ACF, significant spike at lag 1, 8 and 12, and it also the same. Okay, okay, 1, 8 and 12. I say that 12 here barely touch, and I consider it as significant spike. Okay, and then I also have here 1, 8 and 12. Okay, this is the same, but remember, for ACF, this is the order for AR. Okay, 1, 8 for AR, and 12 is for, sorry, for ACF is for MA. Okay, don't okay, don't confuse here. Okay, again, for ACF, it is actually for MA. Okay, for MA, this is, and this is for SMA. For PACF, it is actually for AR and SAR. So this lag here is for SAR, and sorry, for AR, and this is for SAR. Okay, I hope that you don't confuse how you read this significant spike. Okay, so model based on ACF and PACF is actually Arima 212. Okay, 2, okay, 2, 1, because we perform the non-seasonal differencing, and 2, and also 1, 1, 1, because this one 1, and we perform the we perform the seasonal differencing. Okay, so this is basically the alternative models that I choose. Okay, 4 others alternative models based on these benchmark models. Okay, anything that near this, I will call this as model 1, model 2, model 3, model 4, and model 5. Alright, so we reach at the first part. Okay, and how do we select based on these 5 models, how do we select best 3? Okay, and here for optional, for your additional knowledge, I will show you how to perform auto Arima function. Okay, this auto Arima function is we let R to select what is the best model based on our series. Okay, which series? The estimation series. Okay, and based on our output, it will suggest us Arima 301-210 with brief. Okay, it means that when you write the equation, you have a constant value in your equation. Okay, the constant value stand for the drift. Okay, so this is the models that suggested by R by using auto the Arima function. Okay, you can have this as one your alternative models. It's up to you, but it's just an optional. Okay, right, so how do we fit the Arima models? Okay, it seems that all of you don't have any difficulty to perform this step. Okay, you use the estimation part data, and then make sure that the order is correct. Okay, the order is correct. Okay, this is for non-seasonal order, and this is for seasonal order. Okay, and then you run. Don't forget the summary function. Okay, and then you run. Okay, you run. Okay, you run. Right. Okay, so for the estimation part, okay, suppose that I use AIC. Okay, I use the which model that produce which three models that produce the lowest AIC. Okay, alright, so based on this, model 1, okay, AIC, this is the AIC, model 2, this is the AIC, and so on. Alright, so based on this, I will choose model 5. Okay, model 4, 2008, and then model 1. Okay, so that's a model I choose. Okay, now it's time for to perform what we call it as out of sample forecast. So for this step, it is actually quite confusing for you to use. How do you perform this out of sample part? Okay, to model the data. Okay, I will suggest you to use this method. Okay, so that please everyone, you have to use this way. Okay, right, so suppose that my model 1, 4 and 5 is actually the best model based on lowest AIC. So how do I perform? Okay, how do you perform out of sample forecast? You actually perform the N ahead forecast based on how many data set that you hold. How many data set that you hold before you estimate the data. Means that how many data set that you have for evaluation part. You hold how many data. So how do you know? You can check the length of your evaluation data set, the holdout data. So now here you have 24 observation. Okay, now we will perform 24 ahead. Even though that we use N ahead, it for this step we actually have the actual data, for this period, but we want to test whether our model filter is good or not to perform N ahead forecast. So how do we know? We compare how close are our predicted value with the actual value. So that's why what you use is, okay, you use model 1.ex. Okay, model 1.ex ni is actually the models that contain your estimation data. Okay, how many N ahead? It depends on how many holdout data you have. Okay, for my example 24. So I use N ahead 24 and I call the predicted value. Okay, so this is our predicted value based on our models, and this is our actual value. Evaluation.ts, this is the actual value, our holdout data. So okay, let's take a look. Okay, so now it seems that this is the data set that generated based on our models, and this is our original data. Okay, so how do you calculate the error measure? Okay, what is how close are our predicted value with the actual value? Okay, now I introduce you another function, which is accuracy function, which is you will put first the predicted value. Okay, $PRED ni is how do you call the predicted value for this model? Okay, for these models, okay, the N ahead 24, how do you get the value? Use $PRED. Okay, how do you calculate ME and RMSE? Okay, you put accuracy, your predicted value, and your actual value. Okay, make sure that you don't you don't put the actual value first here. It is wrong. This is the correct way to use accuracy function. Okay, even though that your formula is actual minus fitted. Okay, the way you use accuracy function is you put the predicted value first. Okay, and then you run for these three models. Okay, you run for these three models, and based on these three models, you look at the error measure, the ME. Suppose that I use ME, RMSE, and MAE. Okay, suppose that I use these three. Okay, and then you can use all five. It's okay. It also works. Suppose that I use these three, and which models that produce the lowest ME, RMSE, and MAE. Okay, suppose that they're conflicting with each other. I use suppose that two out of these three, they say that this model is the lowest. Okay, as example here, I would say, okay, ME and RMSE for model 5 is the lowest compared to others, but for MAE, this is the lowest. But since that 2 out of 3 say that model 5 is the best, I will choose model 5 as our best model. Okay, and next, before I proceed to model application, I check first whether our model 5, the residual is white noise or not. Okay, by using Leung-Bock test. Okay, so how do I perform? I use box.test function, and after I perform the box test function, it seems that the p-value is greater than 0.05, which conclude that my residual are white noise. So I can proceed with model application and conclude that model 5 is the best. Okay, the best model is model 5, which is Arima 1112 1111. Okay, based on my my previous step. Okay, and for model application, this is also a lot of you confused here. Okay, use this method. Okay, you have to fit the model towards your all data series first before you proceed to apply the models. Okay, but using the order that we identify as the best model. Okay, so it means that this is the end of our or I say that this is our final model. This is the coefficient is the final model which we identify as the best models. Okay, and we perform the end ahead forecast. Now we say that end ahead forecast because of what? Because we don't have the data set in 1999. Okay, we don't have this data set. Okay, so we don't have to compare whether our predict value is okay, closer or not with the actual value, because we don't have the actual value. Okay, we assume that we don't have this actual value. So this is an ahead forecast, and you just proceed with the examples that that previous example that I provide with you. Okay, considering that you perform to all data set and the best models. Okay, the best models. Okay, based on these coefficients. Alright. Okay, so this is model application. I hope that you don't confuse after my explanation, and you can proceed. Okay, okay, with the analysis. Alright. Okay, I hope that my video helped to clear your confusion to perform this project. Okay, right, so that's all from me. Thank you.